Hello.
So please join. Please tell me now, is it okay or not? Am I audible? Am I audible? Okay, fine. So please join quickly. So here I already mentioned that we have to study the relationship between monthly e-commerce sales and online advertising cost. Here we want to predict the monthly e-commerce sales on the basis of online advertising cost. Okay, Ronit. Ronit, I didn't response from you. I didn't get any response from you in the class. Please response. Okay. Okay. Orko Prabhu, Shashwato. Yes. Thank you. Shuman. Thank you. Shayok. Thank you. Pritam. Okay. Thank you. So here, independent variable or regressors is online advertising. This is also called explanatory variable, and dependent variable or response variable is monthly e-commerce sales. I denote online advertising by X. So it is X, and monthly e-commerce sales, that is dependent variable, by Y. This is denoted by X and this is Y. So first you need to compute summation X. Here number of observation, number of pairs is 7. Summation X, summation Y, summation XY, summation X square, summation Y square. Please compute these values and tell me. According to my calculation, I got this value. Summation X is 15.8. Summation Y, that is 3590. And so mean of X, which denoted by X bar, which is equal to 2.2571, and Y bar, that is mean of y, that is summation y by 7, which is equal to 512.8571. Please do this. X bar is equal to, okay, thank you, Pritam. Ronit, please tell me what is summation y and what is summation y bar. Please compute and tell me. Summation xy, this is equal to 990.9909 9. Summation x square is 46.2. Summation y square is 2163438. Okay, please do all these values and tell me whether these are correct or not. Now, Nirmallo. Nirmallo, I didn't receive any response from you. Please do these things and tell me. Ronit, Nirmallo, please do this thing and tell me. And now if I plot this, so please tell me. Okay. Okay, thank you, Shashwato. Ronit. Okay. So SSX, which is equal to summation x square 7x bar square, this is equal to 10.53714. SYY, which is equal to summation y square 7y bar square, this is equal to 32280.9. SXY equal to summation xy minus 7x bar y bar, this is equal to 1806.757. So please do all these calculations and tell me. Thank you, Shayo. So please tell me R, which is a correlation coefficient between x and y. This is equal to SXY by root over SSX SYY. So please tell me these values. According to my calculation, I got this value 0.98. Pritam says SXY is SXX, XSX. No, Pritam, I think you did some mistake. Okay, please check your calculation. Pritam, SXX is some XY is some XO. Yes, yes, yes. You are right. Okay. So 0.9804. Please, Shayok, do this and tell me. So this means This means, this implies the there is strong positive correlation. Yes, thank you, Shornavo. There is strong positive correlation between monthly e-commerce sales and online advertising. Okay, so from R we can conclude this. If you look at the scatter plot, if you draw the scatter plot, then you see that this imply from the scatter plot, Ronit also gets same value. Thank you, Ronit. From scatter plot, we get same conclusion. That means there is strong. Thank you, Arko Prabhu. There is strong positive from scatter plot. We see that all points are close to, I think I write in that way. Since all the points are look like a straight line, pattern of the points or graph are pattern of the points looks like a straight line. So we conclude that there is strong positive linear association between these two variables. That means monthly e-commerce sales and online advertising cost. So from scatter plot, we see that pattern of the points or graph look like a straight line, almost a straight line. We conclude that there is a strong positive linear association between monthly e-commerce sales and online advertising cost, which we get same thing from the value of correlation, which is we already got this value, which is 0.9804, which is close to, since R is close to very close to 1, So we get same conclusions. Now, since our aim is to predict monthly e-commerce sales on the basis of online advertising cost, so the regression equation, so from scatter plot we can use linear regression here for predicting monthly e-commerce sales based on online advertising cost. So the regression equation or regression line is y hat a plus px. Y hat is a predicted value of monthly e-commerce sales, and x is a online advertising which is given. So we knew this thing from our previous class. B is a estimate of the slope parameter or regression coefficient of y on x, which is nothing but a sxy by sx. So please, we already compute this value sxy sxx. So this is equal to, if you look at this, so sxy is our, in this case is 1806.757, and sxx is 10.53714, which is equal to, so please tell me the value. Please tell me the value. I think according to my calculation, I got this value 171.4656. Okay. 171.4656. 4656. Okay. Okay, thank you, Shayuk. And A equal to estimate of y-intercept thank you, Ronit, equal to y bar minus bx bar. So if you put this value, we already compute x bar, y bar. X bar is y bar is 512.8571 minus B is 171.4656 into x bar, which is equal to 2.2571. So according to my calculation, I got this value 125.8349. Okay. So therefore, the regression equation is y hat equal to one to 5.8349 plus 171.4656x. Okay. Shayak, Sxy is not equal to covariance of xy. Sxy divided by n, which is equal to covariance of xy, because Sxy divided by, if you look at the formula of correlation coefficient, R equal to, please listen carefully, R equal to covariance of xy by root over variance of x into variance of y, which is equal to Sxy by n. Sxy by n is a covariance of xy. Variance of x is equal to Sxx by n. Variance of y equal to Syy by n. Hence, if you put all this value, then you see that R is nothing but a Sxy by root over Sxx Syy. Okay. So, since just if you look at the formula, then you see that R covariance of xy by root over variance of x variance of y is nothing but a Sxy by Sxx Syy. Sxx is one summation xi minus x bar yi minus y bar. After simplification, we can write this as summation xi yi minus n x bar y bar. I use last form, that is summation xi yi minus n x bar y bar. Okay. So what is the value, or what is the meaning of this value? That is 1.25.8349, 171.4656. So now I want to interpret regression coefficient as well as y-intercept in the context of this data set. Okay. So this is the interpretation of the result. First interpretation, that is y-intercept. Okay. So if you look at that, when x is equal to 0, then y hat is equal to 125.8349, which is a intercept, y-intercept term. Okay, so what do you mean by this? X0 means what? If this means, in practical sense, if there is no cost on online, X0 means there is no cost on online advertising, then the predicted monthly e-commerce sales is, since the unit measure is $1,000, that means 368, the original form is $368 into 1,000 means it is originally $36800. Similarly, this means $3400. Okay, so y hat, this is a predicted value, intercept is a predicted value when x0, that means there is no cost on online advertising, then predicted monthly e-commerce sales is 125.8349 into 1000, that means 125,834.90. Okay, so that means 125,834.90 dollars. But it is meaningless. Why? Why it is meaningless? Because no cost on online advertising is not possible. So this interpretation is not practically, we write in that way, but it is not practically possible. This means, hence in this case, we have no practical interpretation of y-intercept. So please tell me, are you agree with me or not? So take your time and tell me, are you agree with me or not? Rani, Tarko Prabhu, Nirmallo, Pritam, Sumon, Shashwat, please tell me. Shayo, where, Ornesha, please tell me, are you agree with me or not? Are you agree with me or not? Please tell me. It is not practically possible. Oh, sorry, it is not practically possible. Correct. Thank you. Thank you. Thank you. I forgot to write this thing. It is not practically possible. Thank you. Thank you, Shashwata, uh, for find the typo or rectified this thing. Okay. Thank you. And you wrote it is practically. No. This is my mistake. It is not practically possible. Because monthly e-commerce sales is not possible without online advertising. If you look at, if you use your practical sense, monthly e-commerce sales is not possible without online advertising. But why Intercept means when X0Y had this, that means there is no cost on the online advertising. When there is no cost on the online advertising, we still have a predicted monthly e-commerce sales, and that is equal to 125,834.90 dollars. So this is practically not possible. Hence, in this case, we have no practical interpretation of y-intercept. Thank you. So now, slope. Interpretation of slope. Or regression coefficient. If you look at the regression line, you see that if you slope is nothing but increment. Slope is nothing but increment. That means you can write this thing. The slope of 171.4656 shows that each increase of 1 unit in X, we predict the average of Y to increase by an estimated 171.4656 units. So please tell me, are you agree with me or not? Slope means unit increment. Predicted value of the unit increment. Okay. That is, if you increase 1 unit in X, we predict the average Y to increase by an estimate this. Why increase? Because if you look at the sign of slope, this is positive. That means it means increase. If it is negative, that means it is decreased. Okay. So up to that? Are you agree with me or not? Then I go to the what do you mean in the context of this problem. First, tell me, are you agree with me up to that or not? Please tell me. Please tell me up to that, are you agree with me or not? If you do not agree, no problem. Please tell me your argument. We will discuss. Thank you, Arko. So, Arko will say yes. Please tell me quickly. Shashwat also say yes. Okay, thank you, Shashwat. So, according to this problem, this means for each increase of $1 in online advertising, cost, I think it is better to write, because online advertising cost measured in $1,000. So instead of $1, I write this thing is $1,000. Here unit is 1,000. Okay. So for each increase of $1,000 in online advertising cost, the expected monthly e-commerce sales are predicted to increase by predicted to increase by 171.4656 into 1000, which is equal to 171,465.60 dollars. Okay, so for each increase of in for this problem, slope value of the slope, that means 17.4656 units, means for each increase of $1,000 in online advertising cost, the expected monthly e-commerce sales are predicted to increase by 171,465.60 dollars. Okay, so please tell me up to that, are you agree with me or not? Then I go to the next part. So please tell me, Nirmallor, Ronit, Pritam, Shayok, Shumon, Anuswa, Orko Prabhu, please tell me, are you agree with me or not? Are you happy with this interpretation? Please tell me. If not, please write your comment, we will discuss. Okay, Shashwat, thank you. So, next part. Okay, thank you. So, now we compute. Yes, sir. Thank you, Ronit. Okay, thank you. So, y hat 125.8349 plus 171.4656x. So now, if if you use 7 values of x, that is, okay, Sharnavo, thank you. X is equal to 1.7, 1.5, 2.8, 5, 1.3, 2.2, 1.3. Now using x, 7 values of x, we can easily get 7 values of y. So y hat. Now, if you look at this graph, this points is a observed value. These are the observed value, and I draw this straight line on the basis of these equations. So this straight line implies y hat Please do it yourself in the home after this class. So y hat is equal to 125.8349 plus 171.465x. So if you look at this graph, from this graph we see that observed value are very close to the straight line. So from this graph we conclude that the from the graph we see that points are close to predicted regression, close to regression line. So we conclude that fitting is good. Another way we can check this goodness of fit, that is measure of goodness of fit, measure for goodness of fit. I already told you this in my previous class. This measure is nothing but r squared, which is called coefficient of determination, where r is a correlation coefficient, and we got the value of the correlation coefficient, which is equal to, I need to see this value. So this is equal to 0.9804. 0.9804. So if you look at, I think there is a problem. Okay, okay, now fine. Okay, so 0.98, 0.9804. So this is equal to 0.9804 whole square, which is equal to 0.96. Okay, Shahrukh, I will address your point after this. Okay, 0.9613. So this means 96.13% of total variation in monthly e-commerce wait monthly e-commerce sales monthly e-commerce sales is explained by the sample of online advertising through this regression line. Okay, so which is almost close to 1, and unexplained part, this is the explained part, and unexplained part, that is 100 minus 96.13, that is 987.3%, which is very small. So it is almost explained, that is online advertising almost explain the monthly commerce sales. So this means we can conclude that the fitting is good. So we can use this prediction formula, that is regression line, for predicting monthly e-commerce sales on the basis of online advertising. So using the value of online advertising, we can predict monthly e-commerce sales using this regression, and we get almost close prediction. So Shayok asks me, how will we draw the regression line in our notebook? Shayok, it is very simple thing. You already done this thing uh, in your high secondary level or 10 plus 2 level. Okay, so x is your 1.7, 1.5. For straight line, you need only 2 points. This is enough for you. So you choose two extreme point, that is one, you choose minimum point, that is here minimum is, if you look at the minimum points, I think minimum is 1.3 and maximum is, that is 2.8. Now using this 2 point, you can compute y hat, just put 125.8349 plus 171.465 into 1.3. So this value gives you y hat. Similarly, for when x is equal to 2.8, y hat is 1.25.8349 plus 171.465 into 2.8. So now you use this 2 point, you can draw the straight line. Okay. Shashwat, this is not the question, relevant question. Yes, of course, if there is a error, your mark should be deducted, but depend on your error. Okay, if your error is 0.002, it should not be considered as a error. But if it is difference is 1, 2, etc., it should be error. Okay. So, Shayok, please tell me. Yes, understood. Okay, thank you, sir. Thank you, Shayok. Okay. So, one thing you note, this regression line, you can estimate monthly e-commerce y hat, monthly commerce, estimate monthly e-commerce using this regression line, only the sample range of x. No, you use this regression line for predicting monthly commerce sales only in the sample range of X, and here sample range of X is equal to 1.3 close interval 1.3 to 2.8. So any value lies between 1.3 to 2.8 of X, you can predict monthly commerce value for that value. Otherwise, this regression equation or line may not be give a good prediction. Why? Because out of the range, sample range of X, we do not know, please listen carefully, out of the sample range, out of the sample range of X, we do not know the behavior of X and Y. We use these sample values and we know the behavior of X and Y only on these sample values, and on this basis of behavior, and this behavior very restricted on this sample value, we can compute regression equation. So therefore this regression equation all perform well only on this sample range of X. That means in that example, this we can predict e-commerce within the sample range of 1.3 to 2.8. For example, if I wish to predict 1.7 X, when I predict the e-commerce value when X is equal to 1.7, and we can use this regression line. But if we want to predict e-commerce value when X is equal to 3, we cannot use this regression line, because we do not know outside range of X what is the relationship between X and Y. This is the reason. So please be careful. If you found the question where you ask, or sometimes people ask, what is the value, what is the predicted value of Y when X is equal to 3? For this example, your answer is, okay, you show the computation how to predict this value. That is, you see, you compute this value in that way, 18349,171.465 into 3. After that, you tell, but this prediction is not reliable. Why? Because this X is equal to 3 does not lie in the sample range of X, and outside the sample range of X, we do not know the behavior of X and Y. So this regression line may not perform well outside the range of X. Hence, we cannot predict, hence we cannot use this regression line to predict Y at X is equal to 3. But if X lies in this range, you can happily use this regression line, because we know the nature of the relationship between X and Y in the sample range of X. Okay, so please tell me if we have any problem up to that. So please tell me, have you any problem? If you have any queries, please write in the comment section. We will discuss. No problem. We will discuss it again. So please tell me, have you any problem, any doubt? সায়ক, শাশ্বত, নির্মাল্য, অর্কপ্রভু, রনিত, অন্বেষা. Okay, no problem, sir. Okay, thank you. Thank you, Pritam. Thank you, Shashwato. So now go to the next part. So here is another data set. We do not discuss it in detail. This is your homework, but I need to discuss something here. Here we have to examine the relationship between the age and price for used cars sold in the last year by car dealership company. So here, according to the problem, car age is independent variable and we want to predict price. We want to predict price. So price is here is a dependent variable. After computations, I got this regression line here, that is y equal to 7836 minus 502.4x. I denote independent variable by x, dependent variable by y. Okay. Y hat is a predicted value of the price. So I knew this thing how to interpret 7836, which is the y-intercept. Now the problem is minus 502.4x. In my previous problem, the sign of the regression coefficient is positive, but here it is negative. How to interpret this thing? This means, so here estimated slope is equal to minus 502.4. This means the average car price decrease. Why decrease? Because sign of estimated slope is negative. Decreases, the average car price decreases 502.4 for each year because unit increase in x. That means in that example, for each year a car increases in age. So this is the interpretation of slope for this particular problem. Yes, 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 Pritam. This is due to negative correlation. Okay, so please do all this. First you draw the scatter plot. First you compute correlation coefficient, then draw scatter plot, then draw compute regression equation line, then interpret all the regression parameter, that is y-intercept, regression coefficient, and then draw scatter plot with predicted line, then conclude your conclude about your fitting, then compute coefficient of determination. On the basis of coefficient determination, you conclude your about your fitting. Please do all this thing. This is your homework. This is homework 1. Okay. Now, next that is homework 2. I think, please wait. I will provide you homework 2 and homework 3. Please wait. So please wait. So so I think please wait. Okay. So this is it. So this is another data set. Okay, are you see this thing? Okay, fine. So this is okay. Okay, fine. So this is your homework 2. Is it visible? I think it is visible now, nah? Please tell me, is it visible? Yes or no? So this is your second home. This is your second homework. Orko Prabhu, please use your do not use mobile. Okay, I think it is visible. Okay, I will try. Okay, so okay, now fine. So now it is okay, na? Please tell me, is it fine? So this is your second homework. Please do all things as problem 1. And this is your third homework. Okay, so please submit these homework. So this is third and another homework, that is 4. So according to third homework, please calculate correlation coefficient and linear regression. X bar means here is a x bar means mean of x. This is mean of y. This is standard deviation of x. This is standard deviation of y. Okay. So please do this problem. Okay. And the fourth problem, just find correlation coefficient using these two regression line, where x is the weight of a heart and y is the weight of a kidney. So please tell me, have you any problem? I want to I want to close the stream. Okay. Before ending my stream, please let me know if you have any problem. If you have any problem, please tell me. I will discuss. So now, Prabhu, tell me it is visible now. So these are all homework. Thank you, Shayok. Okay. So thank you. So we will meet again on Friday, same time. Okay. We we will discuss on Friday intra-class correlation coefficient. Okay. Thank you. Thank you. Good night. Shayok, this difficult is very difficult for me, but I will try. Okay. If I take, I think I will finish by October. I think up to October we have a time. Huh? I need, I think, multiple regression. Then multiple regression take 4 classes with practical. Then uh, categorical data, this also takes 3 classes. So 7 classes plus 1. I think I need 8 to 10 classes more. Okay. Okay, thank you.